80 days, and it is going to be a training that is going to include practice all throughout. We are going to be doing most of practice sessions, and then we are going to prepare you for interviews and give you questions. And then I really much wish that you guys should cooperate among yourselves and try to make the best out of these trainings, please. Just for a recap, if you guys did your homeworks very well, you discover that DevOps is one of the top employing talents now in the industry of IT. When you have the knowledge in DevOps, every company actually searches for you. Every company actually searches for you, and they are ready to pay most of your journeys, your residence, everything. So it is a talent that I for me for one, I look at it to be useful in actually investing your time and your money behind it. Actually take some time and money and actually invest in DevOps. So that aside, the good things about DevOps, we see it every day. So let's get into the training proper. So what is DevOps all about? With our last session, we tried to talk paraphrasing the life cycle of software development. So you can see the infinity sign in front of you there. That is the infinity sign that is always being attributed to DevOps. So we are always beginning with planning. We start with our planning. We start writing the code. Programmers will always start writing the code. So before you ever start developing a software, I will always be taking the example of a school management system, because most of us are teachers and we have some of our students here. So I will always be taking the example of a school management system. When we have a school management system that the school really wants to have their system built, they'll always plan everything. After they plan everything, before they will say that, okay, we want a management system that looks like this, it arranges this type of things, then they'll give it to an IT company. An IT company is going to now hire programmers to start seeing, are we going to code in Python, are we going to code in Java, are we going to code in .NET? Those programmers will come and sit down and decide and see what is there to be coded and how to code it. When they have decided, each programmer now will sit down in his own house or in his own locality and start the coding. When all of them now does their coding, everybody sends their code to one particular locality. That is a repository. We are going to come and see a repository, what a repository is all about, and or how many types of repositories are there for version control and all whatnot. So every developer sends their code, and the code comes to that repository where it is being built. The code, what the developers simply write is a bare code. They just simply write a bare code, and then that code now is being sent, integrated together. All the codes from all the various developers is being integrated together, and then it is being built. When it is being built, an artifact is obtained. I'll come to show you what an artifact is, and you will see. When that artifact is obtained, it is being tested. The artifact is being tested. When it is tested, now it is released. When it is released, it is not released directly like it is being released to the public. No, it is not released to the public. It is released to production. That means they try it in production and see everything that was tested as if it is already working in the real environment. And when they discover that that release is successful, they now send it to deployment. In deployment now, they actually take the application and send it to where it is going to work. There even, they are not yet sure that everything is already working very well, but it is already in the environment where it is going to work. That application is being monitored there for some time, where the operation is being done. So the guys that are doing their operations, they carry out their operations while the monitoring is going on. So after monitoring takes place, if there is any problem, they will send it back to the programmers. What do? They will plan, recode it, build, test, and release. So it is an infinity signal, sign that goes over and over and over again, right? So we will use that infinity signal and come down to the various different type of software development life cycles. Now, the infinity signal is a software development life cycle. That means the software development starts from somewhere to somewhere and it comes back. Now, but we always know that with software development, we want rapidity, dynamism, and speed, so that software can be released very fast. So let's come to the software development life cycle and see their model. So we'll have the first model, which is the waterfall model. With the waterfall model, it is as pretty simple as possible. We are going to come to all the various models. We have the agile model. With the agile model, processes are occurring in bits. That means instead of developing the whole project all together and then you go and deliver it, we start delivering the project in small bits. We'll come to that and see how it occurs very clearly. So look at the waterfall model, the way it is presented to you. We are going to discover that in the waterfall model, processes are just like a waterfall. You know the way a waterfall structure is, it comes and then it falls. The requirements are gathered from here, and then when the requirements are gathered, analysis are being done. Why should they analyze? They analyze because they want to see what type of design will come out, and then after the design is already established, they will then go down to start the coding. When they code, they start the testing, and when they test, they send it to whether the software is being accepted or rejected. If it is accepted, fine, it goes to production. If it is rejected, it goes back to the planning. So there are so many disadvantages with the waterfall model. Disadvantages are too much with the waterfall model. The disadvantages are, it is difficult to estimate time and cost for each phase of the development process. What does that mean? In the waterfall model, you cannot tell somebody that we are going to finish your application in 5 months, in 3 months. They always do the things and realize the time they need to do it on the field. So they don't have a specific time limit. Programmers always fail because when they promise that we are going to deliver the application in 2 months, 3 months, they will always fail. They will discover themselves delivering the application after 7, 6, 8 months, right? Once an application is in the testing stage, it is very difficult to go back and change something that was not well thought of. I explained this last time. So once you are already having an application at this level, at the level of testing, and you discover that there is a problem which you need to solve here. If there is a problem which you need to solve here, you are not going to solve that problem at this testing. It is not possible for you to solve the problem at this testing. You are going to come back and solve the problem at coding. And before you solve the problem at coding, they will have to reanalyze it and redesign it so that the problem should fit with the design that is there before it is being solved at the level of coding. So what will happen? There will be a lot of time that will be involved in it. And then the model is not good for complex and object-oriented projects. Yeah, those of you who are here that have already done Python, I think on there you guys did Python and you did object-oriented programming. with when you come with the waterfall model, you will discover the various difficult setbacks when you are doing using the waterfall model, because when you do that, a simple change will cause you to destroy the whole of your code, right? Not suitable for projects where requirements are at a moderate to high risk of changing. Yes, just like we said, if you are taking the waterfall model, if you are taking the waterfall method of developing application, you should be sure that once the people give you their requirements, they will never change it. They will not change it. And in today's world, you cannot have a world where there is no dynamism. People, or human nature is prone to mistake. When they talk about human nature, they talk about mistake. So human nature is prone to mistake, so we'll always make mistakes. So this type of method will never be good. So because this type of method is not good, what is the method that is now better? We have the agile method. Now in the agile method, agile development model is also a type of incremental model. What do we mean by incremental model? We'll see it. Software is developed in incremental rapid cycles. This results in small incremental releases, with each release building on previous functionality. Each release is thoroughly tested to ensure software quality is maintained. Now look at something here. When we come here, you look at this website. This website has a lot of things. It has personnel, it has privilege, it has wealth, it has private, it has business, it has corporate, it has all these things, right? These are all modules in the website. They are all modules. So in the waterfall method, all these things will be first of all written down before starting coding. But in the agile method, that is not what will happen. In the agile method, the personnel will be developed first. While the personnel is being developed, it is sent to testing. Privilege is being developed. While privilege is being developed, it is sent to testing. Personnel is being sent to production. Word is taken for development, right? We are going to have a situation that looks like this. Look at what we are going to have with the agile method. This is what we are going to have. Here's my pins. All right, this is what we are going to have. While maybe let's say the service for personnel is being developed, here. When it is developed, what will happen? It has been developed. This is let's call this stage development. Then there is another stage that we are going to call testing, or first of all building. Then there's another stage we are going to call testing. Then there's another stage we are going to call deployment. And then the last stage we are going to call acceptance. Now this is what happens here. Let's put it this other way. Okay, this is what happens here. Once the development team is developing this application, when it finishes developing the application, what happens? It is developing just maybe the personal part of the application. After that personal part has been developed, it is being sent down to the building team. The building team takes over and start building the application. Once the building team is building the application, what happens? The development team is going over to maybe the the other part of the website was what? Privilege. The building team is going to the privilege. While the building team is going to the privilege, the development team is in the privilege. The building team is taking the first part of the software. The testing team, this one is finishing. The testing team is taking over it. As the testing team is taking over it, the development team is the building team is taking over the privilege. As the development team is taking over the privilege, the building team is taking over the privilege. The development team is moving over to the next module. Let's just call module 1, module 2, module 3, right? When this development team is in module 3, the building team is module 2, the testing team is in module 1. What will happen? That will keep moving. As the development team is moving to module 4, the building team is moving to module 3, the testing team is moving to module 2. Right? As that is happening, the development team moves to module 5, building team moves to module 4, the testing team moves to module 3, and then development team keeps moving to, please, it moves to module 2, right? And then the last part of it is when the development team moves to module 6, the building team moves to module 5, the testing team moves to module 4, the deployment team moves to module 3, and then the acceptance team moves to module 2, right? So we'll have a line that we are going to arrive, what we call the silence line. In this line now, the whole team is in action. The whole team is in action. Now, because in a development, in a software development company, these are the various teams that are there. You have the development team, that's the people that write the code. You have the building team, that's the people that assemble the code. You have the testing team, that's the people that are testing the application. And these are the ones that are deploying the application. Then these are the quality checkers. They are actually checking whether everything is okay to accept the application. So they call this one the silence line, because when the development guys are busy developing, the building guys are talking, there is still noise in the room. And then when the building guys are already building, the testing guys are talking, there is still noise in the room. When the testing guys start testing, the deployment and the acceptance guys are still chatting. So when everybody is finally occupied, we call that the silence line. Now the whole group, the whole network is now silent and actually working. But look at what happened. It took how long for that silent line to actually occur? From the beginning, the development team is already at one level. They are already at almost a fit level. They can take how long to reach this level? Imagine that they are at this level when the acceptance team is just starting their work, which means the development team will start their job might be 2 weeks before the acceptance teams will ever come to place. The agile method is not also that very much practicable. That is why we will also come to see problems with the agile method. We'll see that there is delay. In spite of the model, still there is delay. There's gap between development team and operations team. There is still delay. So when this delay occurred at the agile method, people started thinking, and that is why people brought up the DevOps method now, where in the DevOps method, the operations team responsibilities and the development team's responsibilities were all held together as one. Because here we are going to name you the operation team responsibilities, which is installation of server hardware and operating system, configuration of servers, network storage, monitoring of servers, and response to outages. The operations are those guys that are always waiting after the application has been built. They are the ones to run the application and make sure that the application keeps moving. So they are the operation guys, right? So their job is as many as possible. So now, reasons for DevOps. So why will DevOps come in? DevOps will come in why? Look at this, our simple demonstration here. If they started this development and these DevOps guys could do the building, testing, deployment, and acceptance, if these DevOps guys could, if the developers could do it, would they need all these people? No. They will just do the application. As the application is being done, if they had a way of just sending the application, this very particular module for testing, they will just send it for testing. So DevOps is just actually tools that have been developed that automate these processes. All these processes like this are going to be automated. So why should we call it DevOps? We call it DevOps because anybody can manage the tools that this automation process is going to function with. Both the developer can manage these tools, both the operations engineer can also manage the tools. So being capable of managing the tools that automate these processes, you are called a DevOps engineer. I hope you understand exactly what a DevOps engineer is. So the DevOps engineer is that person who is capable of managing all these tools. When you are capable of managing the tools that are going to cause building, testing, deployment, and acceptance, and making the process automatic. Not that these testers should come and start working, builders should come and start building, deployment guys should come and start deploying. No, we do not do that again. We do everything automatic. That is the aspect of DevOps, and that is where DevOps is powerful. So the solution to that time lapse that the agile methodology faced was DevOps, right? So we are going to see the various tools that we are going to use and that we are going to be studying for the next two to 3 months. We are going to see those tools. But before we see the tools, let's look at the importance of DevOps. What has DevOps eliminated? DevOps is a methodology that promotes collaboration between development and operations team. This allows deploying code to production faster and in an automated way. It helps to enable rapid deployment. That is the part of DevOps. Rapid deployment. Now guys, you might be thinking, why should there be rapid deployment in applications? Are applications that robust? Look at something. When you want to go into an application, when you want to sign into, when I am in Google and I need to sign into maybe Ethiopian Airways, let's just use this without any publicity, please. Ethiopian Airways has not paid me. Let's go to Ethiopian Airlines. Now, if we are in this place, Ethiopian Airlines, if visitors that are visiting this website, this is the website Ethiopian Airlines, you look at something, there is something here. Your next adventure is just a search away. Now, where are you booking? You are booking your flight from maybe Douala, and you are going to maybe Charles de Gaulle. Fine. You see, immediately it comes out. If a user complains that when I put in my information, the flight does not come out immediately, that flight does not come out, I want that once I put in this information, I should see the flight immediately, and everything should be happening. I should not come and be trying to look at this one. We have not seen the flight, but normally, yeah, one way, we take one way, and what should we do? We should start searching for the flight, but we cannot see the flight. I can't see the flight, so that is a problem. That is a problem, and this problem was reported, and then the builders of this application has to go back immediately and correct it, so that when you fill all this information and fill everything, and you come and you choose your day that you are flying, you click it, you should just see the various flights that are available for you, right? You should just see all the flights that are available for you. A button should be here to say search for the flight, and then you search for the flight. So this is a problem at the level of this application, right? So if this problem arises, what will happen? The developers that have built this application have to go back immediately, correct it, and put a button here immediately. So with DevOps methodology, it is as easy as 1+1 to come back and put that button. But with waterfall and agile methodology, it will start be a time consuming factor. All right, so these are the tools that we are going to be using. We are going to be using a series of approximately 9 tools. Yes, as I said, when I look at your participation, I don't see there are 2 more people that are interested in joining the program. They are not there. I see I wish that everybody must have done Linux, but what I'm going to do is I'm going to skip Linux, and we are going to do Linux on a private day, because most people that are here, I think they are good with Linux. We are going to put some 2 extra sessions, and then we are going to do Linux and finish with Linux, because everything before you do DevOps, you must be very versed with Linux. Without you doing Linux, you are unable to do Linux. So these are the various tools that are going to automate our process. We are going to use Git, we are going to use Maven, we are going to use Jenkins, we are going to use Docker and Docker Swarm, we are going to use Kubernetes, we are going to use Ansible, Nagios, and Terraform. Now, to call for your attention, these are a chosen choice of tools, which means each tool has what it plays, but that tool is not the only tool in the market. Like, for example, I'll show you Git. Git is a version control tool, which we are going to do now. It is a version control tool, and it is also a source code management tool. But there are so many version control tools in the market. Okay, there are so many version control tools in the market. So we choose Git because Git is the most widely used version control, and it is highly developed. It is more advanced. Maven is a build tool. We are going to be using Maven for building those applications that programmers have written, right? And Maven, there are other build tools too. Jenkins is a server on its own. It is a CI tool. You will come to understand what CI is all about. Continuous integration. Jenkins, there are so many tools, but Jenkins is the main operational tool. Docker and Docker Swarm. You must have heard about Docker. We are going to talk a lot about Docker, and Docker is going to be your main thing. So this is where you are. If you are weak whatsoever, please, Docker, Kubernetes, and Terraform. Ansible. Docker, Kubernetes, Ansible, and Terraform. Follow the lessons to the institute. Follow the lessons. All questions in most interviews are Docker, Kubernetes, Ansible, and Terraform. Most questions. Git questions are direct. Maven's hardly have questions. Jenkins questions are most of them just like 2 questions or 3 questions in security. But most of your questions in the interview will come from Docker, Kubernetes, Ansible, and Terraform. Then they will always ask you some questions in AWS. So it is always good to do AWS, because we are going to do AWS DevOps. So if you have not yet done AWS, it is going to, although we are going to do the 10% of AWS that is needed for DevOps, but if you have not yet done AWS, it will be difficult for you to understand some concepts when they will be explained, because we are not going to do load balancing in DevOps. We are just going to use it, but a host of load balancing was done in AWS. So it will be good for those of you who have decided to do it without doing AWS. It will be good for you to take out some time and go back, check on those topics in AWS, and try to go through them. Okay, Linux, the highest thing that is always asked in Linux is the file system, how to change the file system, because you all constantly be changing the security file system, so you will constantly be changing it. So those questions are going to always be asked in the interview. Okay, all right, at this level, please let us pause and hear questions for what people are having in mind before we see if we can touch Git. Any question, please? You unmute and you talk.
Good morning, sir.
Yeah, good morning.
Can you get me?
Yeah, you're alive.
Yes, I only have a question on one terminology you mentioned there
Yeah.
about automation, right? When you say something is automated, are you talking about automatically done, or what are you meaning there?
Okay.
Or is it a process?
Okay. It will be difficult for you to understand automation right now because you have not yet actually practiced the manual part of it. Generally, what happens is that when a software is built, okay, the artifact is generated. What is an artifact? Let us see what an artifact is. When you go online and you want to download something, let's say you want to download VLC player. When you download your VLC player, I think I have a host of them downloaded here. When you download your VLC player, what will happen? You are going to have an artifact that will be sent to you, right? This is how the artifact will look like. This is how the artifact will look like. This is an artifact. Okay, it is an artifact, and this is the version that has been zipped. Okay, so this artifact, now you have to install it. An artifact is just some sort of a logo of that application which you have to install, right? This artifact, do you see the code that is behind it? No, you don't see the code that is behind it. You just see this VLC stuff, and you just need to click it and it gets installed. Okay, so this is an artifact. You don't see the code that is inside it. So the code that was written for this application is embedded inside. So the code has been built into an artifact. So you cannot see what was written inside here as code. You can no more see it. So they used a particular application to build this code into this artifact. Okay, and before building the code, they had to go to a physical computer, install that artifact inside that application inside. There was a computer like this one. They went to that computer, they installed Maven inside that computer, and then they took the code that was generated, the code that people wrote. People could be writing their various codes. Code is coming in so many copies. They took this code, somebody actually took this code and then put it inside this computer or this EC2 instance, and then launch some sort of an activity that was executed in this computer. At the end of the day, this code was built into an artifact, and then he took that artifact and then sent it to the guys that are doing testing, deployment, and acceptance. Somebody actually was doing that job. Okay, but now when we are talking about automation, we don't need somebody to be taking this code and actually building the artifact from it. We don't need that person. We just need that once the code is written and the developers send the code somewhere, the building process takes place immediately, starts building itself. The testing project goes automatically too. It starts testing. People are only folding their arms and watching what is going to happen. It's like building something from the beginning and then just pressing one click, pop, execution, and then you are just waiting for the results to come out. You just see the results and you are shaking your head, right? That is the meaning of automation. Is that clear? Is that clear, Declan? Is he even still there? Any other question?
Yes, sir. Please, I want to know if there is any. In fact, I want to. You have, from what I understood, there were two roles before. There were the developers and those responsible for operations.
Yeah.
And DevOps came like to kind of join. It's kind of automate the deployment.
Yeah.
if I understood very well.
Yes.
So now, what two roles or what are the roles you're now going to have? As from what I understand, we have developers. Are we going to have operation team again, or just developers and DevOps?
Okay. That is a very good question. What happens is that there are always this is what we are having. There is always we have the developers. We have the developers, and then we have the operations. Good. Now we are talking about DevOps joining developers and operations. That means somebody has to go off. Somebody needs to go off from here. Who is going off? That is the question, right? We are joining developers and operations. That means somebody's job is going off. The person's job that actually goes off is the operations guy, right? So nowadays we have developers, and then we have DevOps engineers, right? So we have developers plus DevOps, which makes the engineering core now. So we do not have operations now again. Operations have gone off. So when you are coming for developers will always, well, as the DevOps engineer, please, they will always ask you, are you a DevOps engineer coming from the operations or coming from the development? Because people that studied in DevOps either came from operations or from developers. So they will always ask you in DevOps, are you coming from the developer or from the operations? But most of us that are joining DevOps, we are joining DevOps from the operations, okay? And it is always important now that when you are joining DevOps from the operations, there are a lot of things that you are going to do at the level of development, because there is a lot of scripting. You are going to script at the level of Batch, you are going to script with Groovy, you are going to script with Python, you are going to script with Java. All right. So there is a lot of scripting that is going on here. So you discover that you, the operations, you will be doing the job that developers used to do, and developers, you will be doing the job that operators used to do. So the two of you are just coming together now in what we call DevOps. But the developers are still there because code still needs to be written. Now the fear, we have a very big fear in the market right now, and if you are not concerned with that fear, then there's a problem with you. AI is coming up. AI is coming up, and AI is seemingly going to wipe off developers. AI seemingly is going to wipe up developers, because now it is possible to just type on an AI frame that give me a code of a website that is this and that, and then you click enter. That code is being generated for you, and then all you do is you just change the small changes from the code, and then you build. So developers are in serious risk. Developers are in high serious risk. We are pushing ourselves towards DevOps because at the end of the day, DevOps is more human oriented in thinking, because you need to put the tools together in order for the operation to take place, in order for the execution to take place. So the tools need to be put together. So that's why with us at the level of DevOps, we still have, at least it is projected that for AI to do what we are doing, we still have at least 70 years for AI to do what we are doing. That means AI go and program a computer, AI comes and select the particular tool, go and put in the computer, AI decide the quality test for that particular software, AI decide how the customer wanted the software. AI is still far to take over DevOps, but AI is already at the verge of eliminating developers. So for those of us who are thinking of going into this, we think of DevOps, not developers again. Is that clear?
Yes, sir, it's good.
Okay, good. Any other question, please? Okay, let us introduce Git as fast as possible before we terminate in the next 15 minutes or so. All right. Okay, we want to look at what is version controlling. The term version controlling. Version controlling actually is that, let's come along here please. Okay, with version controlling, this is what happens. There is a programmer that is here, there is another programmer that is here. This programmer is in Europe, this one is in America, this one is in Africa, and this one is in Asia. All of them are doing programming and they are submitting their code to a server in the United States. Right? Good. This programmer writes his code. He writes his code, sends it to a server in the US. This other programmer writes his own code, sends it to that particular server. This programmer writes his own code, sends it to this server. This programmer writes his own code and sends it to this server. Right? At the beginning, the first code that will enter, the very first code that will enter is this. This code will enter here. This other code will enter. This code will enter. So all of their code will enter, right? All of their code will enter into the server in the US. Something like this. Good. Now, if this developer was asked to develop a model, let's say he was developing a banking system and he is developing a model for savings, for example, he is developing a model for savings, and this other developer is developing a model for loans, a module for loans. This one is doing maybe overdraft, and this one is doing maybe developing the section for online deposit. All these guys are writing the code for this application and sending here. Good. Now this guy writes his code, sends here, and then the code is built. After the program is built, generally after some time, this one writes his own code and sends here. The first person that sent the code was this one and the program was built. The second person that sent the code was this one, the program was built. The third person that sent the code was this one. So now if they want to know at what stages who sent which code, because it is code, it is not like it is series of blocks that come differently like this. It is code that is integrated. You have ever seen a software code, right? Let's try to look at the software code. Look at the way a software code looks like. Let's look at the way a software code will look like, please. Let's enter. Is the University of Yaoundé one having an address? University of Yaoundé 1. Are they having an address and a website? That should be your work, Roberto. If your university is not having a website.
We are working on that.
You are still working on that. That is bad. I see u1.cm. Might be. Okay, we got something. At this. That's great. We got something. Okay, and there is even Français Anglais. That is very nice. We were searching, we could not have seen this. Okay, this is the website of the University of Yaoundé 1, right? It has been built by software development guys. You see, when you come to the website, information is found on the website, and this information that is found on the website should be changing, right? And since we are in a bilingual country, the information should also be both in English and French. This is a very standard version of a website. Okay, I think we can recommend the University of Yaoundé 1 for that. You will see everything that you can see. The faculties are there, everything is there. Okay, so if you want to see the code behind this this website, right, if you want to see the SSS code, the CSS code, and the HTTP code in your Google browser, you can go to view page source in Chrome. This is the code that is running that website that we have just opened like that. Look at the code. This code might have been developed by different people. Okay, it is not certain that only one man will sit down and write all these things. It must have been developed by so many different people. So you see, the code has to come from different sources, and then it integrates itself. This is the code that has been written. All this code like this. It is not something that one person can write. Okay, so what is version control then? Version control is that each and every code that every person sends is committed, which means savings is committed as a version, loans is committed as a version, overdraft is committed as a version, deposit is committed as a version. Why do they do this? They do this such that every code can be rolled back. For example, a developer can develop a code and by mistakenly sends a pornographic photo inside the code. It happens. Okay, he instead by mistakenly sends a photo, a pornographic code. There is something with this website. You know something? It is not responsive. Now, a developer can mistakenly send a pornographic picture, and instead of seeing this home, very nice, beautiful picture here, you are instead going to be seeing a pornographic picture. Or a hacker can hack the website and places the photo of, might be somebody that he has edited. Example that there was a time in which they placed a photo of Dorothea Njoma. Her face was there, but the downside of it was a lady that is standing naked, right? So in that type of a way, what will happen? Something must have happened. A code has come from somewhere and integrated into the server, and when that code integrates into the server, they will simply do what? They will simply roll back. What they will do is they will simply roll back to previous versions of the website. If an attacker attacks the website and puts something there, what they do is they simply roll back. Because when they will roll back, whatever the attacker put there, that version will be out. You get that? So the reason why we always talk of version control is that each and every code that is being sent by programmers should have a particular version. Okay, so what is Git? Git is a version control tool. Okay, let us see how it functions. For those of you who do not yet have Git, I think all my AWS students already have Git installed in their computers. This is how you install Git in your computers. Please, you just go to Google and then you click on Git download. When you click on Git download, you will see the first one will be Git SCM. You have something like Git source code management. SCM stands for source code management. When you take Git source code management, I am using a Windows computer, so the latest version is 2.4.1. You then download it from here, and my computer is a 64-bit processor, so you should know which bit is your computer. My computer is a 64-bit processor. I will click on this. You see the application is being downloaded. It's just a 57.82 GB application. If you don't have Windows, this download manager, might be the download will occur somewhere up here, or if you are using Chrome, the download will occur somewhere down here. But I am using this download manager, which I like so much, so I direct where it is being downloaded. I can decide where it will be downloaded, or I can just decide that it should download itself on the particular page. So it is not heavy enough, just click it and it will download. But I hope the internet in Cameroon is such that it will download this fast, because there is trouble. So you see, this is the version that is existing. I already had one version, so this is the second one that I've just downloaded here. So when you download the application, it's just like a normal application, like your normal VLC application. You just click, it's an executable application. You just double click on it. It is going to install. It is going to install something like this, and then you accept yes. So but for me, I already have the application, so there is no need of installing it again. So what will prove that you have installed the application? What will prove that you have installed the application? When you install the application, please, this is what you are going to see. You are going to see something like this. When you right click on anywhere inside your repository, you are going to see these two things here: Git user interface here, Git bash here. These two things are going to occur, right? You will see the two of them. Whenever you right click anywhere, you will see them: Git user interface here, Git bash here. Okay, those are the two things that are going to appear. All right, so when they appear, how do we use Git? How do we use Git? What is Git? All right, now when they appear, let us just simulate a programmer. Take for instance, I am a programmer. How do I use Git? How will I be able to use Git? Okay, as a programmer, I want to use Git. Go to first of all, open if I want to start coding a new program that is just as new as anything. So I go to my DevOps projects. I start the program that I want to start coding. I look for the name of the program. Maybe it is a school management program. School management. That is the project I want to start building. Right? I open my school management project. What would I do? I will bring in I'm certainly coding the program with an editor. The editor can be anything, but for our purpose, let's just use Notepad as our editor. When you want to code any program, you code it in any editor. There are so many editors. There's VA editor. There are so many different types of editors. So we wanted to see how Git is being used, and we were at the level of saying that we have created a folder that is the school management, And then now we want to use Notepad and start writing. We are developers, we consider ourselves developers now. So let us start writing our code. We start writing our code. Now we are writing a Java code or a Python code. Let's write a Python code. So we are going to write a Python code in Notepad. We open a Notepad, we start writing our code. Let's write whatsoever a code it is. Don't be afraid. Okay, let's actually write a code, please. Let's actually write a meaningful code. Let's write an HTML file. HTML file. For those of you who have done HTML, it starts with what? There is always there
less than and greater than.
There's always the head. Then that's good. Thank you very much. There's always there less than and greater than signs in front here. Then we have the head is that, and then we have
yes, the body,
and then we have the end of the head, right?
Yes, the end of the head before the body.
The end of the head, where we have slash.
Slash is in front, sir.
Pardon?
The slash is in front.
Okay, it is in front. Like that?
Yes.
Okay, then we have the body. This is an additional. We are not doing web designing, but this is just something that if you are smart, you catch it, because it is this is actually how HTML is designed. Okay, so if you are smart, you are going to catch it. So anything I write in here, like welcome to DevOps training, we actually need to also close there. Close the HTML, the HTML tag. All right. Okay. Now we are going to, this is our code that we have written. This is just a code that we have written, and in the body, what should we write in the body? We should write in the body
anything inside will be B tag or each one.
Yeah, let's write just like we are happy to learn. Right, and let this be H1. H/H1. Okay, let's save this.
So you say have to add the less than and greater than on H1.
Okay. Yep. I hope you see now why collaboration will be necessary. We have somebody that has done scripting, and he's here with us. So tap from the resources if I were you. So let's save as, we are saving as all files, right? and then let's save as school manager dot html, and we are going to save it inside of that our development projects, and we are going to save it inside our school manager. Now we save. Good. We have written a code, and this is our code. This is the code of a project. We can open the code there. You can open the website and see what we have written. Let's open the website. Open with Google Chrome. Let's see. Wonderful. This is our website. Okay, welcome to DevOps. We are happy to learn. This is our website that we have just created. Okay, teaching for creating website. Enjoy. I hope you are going to pay for this. Okay, this is our website that we have just created. Now this is a code that we have created, and we need now to send our code, because we have created our code. We need to send the code to, remember where we are. We are in Africa here, somewhere here in Africa. We need to send the code to the US, to the repository. Okay, but before we send the code to the repository, we have to do something at our local repository. We have to versionize the code with Git. Okay, this is the practices that you are going to do with Git before you actually send the code. Here are the practices. You are going to come to where the code is found. Then you are going to right click, and then you are going to open your Git bash here. Wherever the code is, you are going to open your Git bash there. Now there are 3 stages in Git. Git keeps its code in 3 stages. The code that we have right now is what we call the untracked stage. We are in the untracked stage of the code. How do we know that we are in the untracked stage of the code? We have to initiate, first of all, our repository. To initiate that repository, we have a code that we always run, which is git init. Right? When you launch git init, the repository has been initialized. Right? You run git status. You see there is a school manager here. This one is showing red. Why is it showing red? Because it has not been versionized. It has not yet been versionized. In order to versionize it, we are going to add it to our staging directory. A staging directory is just a virtual place where you just say that we have visualized this particular code. Now it is ready to be committed. Right? When we visualize the code, in order to visualize the code, we just simply use git add hyphen this dot at the end. This dot at the end should always be there. It shows that you should take all the files that are in this directory. This dot at the end. When you use git add hyphen this dot, it shows that you should take all the files that are here. You run. Now you run again git status again. What are you going to see? When you run git status, you are going to see that the file now is in green. That means it is ready now to be committed. If you run now the next code that we are about to run, then that particular file now is already having a version. Right? It is already having, that particular code is already having a version, which means if there's a problem, we can roll back to that version which we just committed. So the next code that we are going to commit is git commit. Now when you run the version, there is always -m, and then you write what you are committing. Right? In this one we are committing first page of our DevOps training website. You see what you are writing? That means this is the very first page that we ever wrote in our DevOps training website. So if we want to in future roll back to this very first page that we open like that, we can roll back. So we have committed. You see, when you commit, you will see here one file changed, right? If you run git status again, you will see now that there is nothing to commit, right? Nothing to commit. Okay, so there is nothing again to commit. Everything has been committed. Now our code, let us open our code. This is our code here. Okay, it is already running, everything is fine. What if we change something in our code? What if we change something in our code? Take a look at git, please take a look at what git is saying. We are running git status. We run. Are you seeing? Nothing to commit. Let's come now back to our code. Where is that our code? Here is where our code is found. Now when you initialize the repository with git, you see that this small.git folder is now available here. This is where most of those things are stored. Let us open our code and do a light change from there. Let's open with opening the code with Notepad. Okay, this is the code opened. Okay, now let's say that inside the head, we wanted to write something now like a paragraph. I wanted to write like let's say DevOps is one of the leading expertise in the market. Right now we have added something. Let's just see. Let's go and open our code and see whether anything was changed. You see, there is something that has been changed. We have now DevOps is one of the leading expertise in the market. Now it has been changed. Let us come back now to our git. Run git status. You see, there is something that has been modified. You see, now it has been modified, and whenever you modify it like that, what will happen? You need to run git add. You need to add it. It goes to the staging area, and then you run again git commit -m, then you write what you committed. Root on the body of our website. So anything that you change in your code, you will write there what you changed and what they changed it in that commit, so that when you give your code to somebody, he can see the various changes and what actually happened in those various changes. Okay, now it has been changed. If I press git status now, nothing to commit. At this moment now, I am free now to send this code to my general repository. Where? To my repository now here in the US. I am coding in Africa, but I am going to send the code here in the US. Okay, so that is how. Let us go back and see, was there any change? There's no change. We simply committed. So let us refresh. There's no change. Okay, so that is what we are supposed to see today as far as the introduction and git is concerned. Any questions, please?
Yes, sir.
Yeah, go on.
Please, can we upload, or what's the name? Can we commit a whole folder or many files at the same time?
Yes, exactly. If we have here, like we are having one file, right? We are having one file here. If there were two, like, okay, let us just do this, please. Let's just do this and then we conclude. Let's do a CSS, right? In a CSS file, how does it work? We have let me open my Mangambe box. Okay, my folders. Anyway, let us create it. In a CSS file, we will certainly have how to make our page beautiful. Not so we can have some sort of we say color. Open our brackets, braces. We say color equals red, and we wanted to tag h1. We say color equals red, and then we close, and then we save our file as what? We save our file here as school manager.css. Okay, there are now two files that are existing in our code. There are two files that are existing. We have a CSS file and we have an HTML file. The CSS file is what gives beauty to the HTML file. Okay, so we want to commit all of them. So if we go to our git bash and we run git status, we'll discover that there is something that has been added, school manager.css, right? So here we can decide to say git add school manager. You get it? It will add only school manager css.css, right? It will add only school. But if you say git add dot, that means it is going to add everything. Whether there are 200 files and folders, it is going to add all of them. Okay, when you say git add and then you put that dot behind, it is going to add all the files and folders that are there, and you are going to commit it. Commit -m css file added. You have committed. So you run now your git status, nothing to commit. Okay, so you can add as many files and folders as you want just with that extra dot. But if you want to be adding the 115, you can be precising the file name. All right, is that clear?
Okay, okay, sir.
Any other question, please? Any other question? Okay, I want to give everybody to rate the class before we go.
Okay, I have a question.
Yes.
With DevOps, are we going to be using GitHub or only the Git?
We have not yet come to the remote repository. We are still at the level of local repository, right? Because when you start talking about GitHub, I know you are far deep into programming. When you start talking about GitHub without actually defining what GitHub is all about, people are going to get confused. So we are still at the level of our local repository. So generally, what I mean by sending the code to a browser somewhere in the United States, this is what we are going to be talking about GitHub here. our remote repository will be, we are going to use GitHub for our remote repository. Okay, this is what we are going to do, but we really need to take time and introduce what is GitHub and how it will be used, because all this code is going to be actually uploaded to GitHub, where now from GitHub it will be removed and then the application will be built. It is just code that is uploaded here, so the code will be removed from here, then your application is going to be built as a DevOps engineer. Code is uploaded here and then removed like this, and then the application is going now to be, your application is going to be built here. This is where your application is going to be built after the code has been removed. You have an application that is built here. Okay, everybody upload their code to GitHub, and then GitHub builds the application here. So our real studies will be seeing how to remove this code and build this application. Okay, is that clear?
Okay.
Yes. Any other question? Declan, you have been a bit quiet. Is everything clear?
No, it's okay, sir.
Okay, all right. Okay, if everything is clear, we hope that we had a good introduction, and please try to do your most research, install Git, try to work with stage files, try to see how you can move files from on track files to stage files and commit them, and just try to practice it all around. Install it and try to practice it all around. Tomorrow we are going to look at how to configure Git, because we have not yet configured Git. You just installed it like that. We have not yet configured it. Types of files. We are going to get into what is initiation, more files into staging area, staging files, more files to local repository, how to see list of all the commits. We have not yet we have just simply done a list of commits. We have not yet seen how to take a look of how many commits we have done. We have done a series of commits. We can see how to take a look of at how many commits we have already executed. So that is going to be in our tomorrow session. I think session will still begin at 9 a.m. Thank you very much. Let's not be too long. See you tomorrow.
Excuse me.
Yeah, you're on.
Please, after this class, right, without recording, I would like to share my screen and you help me with something.
All right.
If
No.
at all you have time.
Just about 10-15 minutes. Can that be okay?
Yes, I'll be a little bit fast. I want you to help me with something. Yesterday I was practicing on EFS and I encountered some problem.
All right. We'll do that immediately after this. All right. See you guys tomorrow.